Okay, so if we can start just looking at the data center and maybe data center hosts IT infrastructure. So the data center IT challenges, which have, I guess, been the catalyst for you creating this cool data center solution. Can you give us a bit of background?
Yeah, absolutely. So I think it's well understood that the industry has a set of challenges which are both which are technical, economic, and to some extent sustainability driven. And there's differences between the core data center and what we call the edge. But looking in the round, we're at a point where significant change needs to happen. Very simply, the chips are absolutely getting hotter. There's no doubt and debate about that. And we're at the limits of what air cooling can do. So the next generations of chips are already in the 253, 350, 400 watt levels, and air cooling just simply will not happen, or will not be able to persist in cooling those kinds of chips. So it's going to depend to some extent on the application, but you need to move to liquid cooling. And our approach to bringing out our whole platform, if you like, of technology that we brand under Cool, was that if you liken it to software, in a new marketplace, you get lots of point solutions. So there's lots of things out there that can cool a little bit of something or can cool part of something. But over time, you start to really develop a much more coherent platform that comes through, and that can be allowed to be deployed in many locations. So our approach is a function of both the technology itself, but also the business model, recognizing that you need to deliver up solutions that work with the technology of today, that work with the supply chains of today, and so on. So recognizing those challenges around sustainability, we cannot continue to just use as much electricity and water as we do. And the technical limits of what we're able to do with air, a change is needed. And then it was, how do you do it in such a way that allows the customer the least possible pain, and having made the leap, gives them the most possible benefit to build out whole new ways of doing things.
Okay, and in a minute we'll come on to the actual solution itself, but before we do, you've obviously collaborated, or whatever you want to call it, with Lenovo, Schneider Electric, and I think Avnet. So can you give us a bit of an idea of how that, who was the prime mover in that, how this sort of collaboration came about?
Yeah, absolutely. Thank you for that. So we really saw that emerging was a real opportunity around the edge. The edge of network was a place where AI and HPC innovations were going to come first and fast. And we were going to need to deploy that to new locations, be it agriculture, be it automotive, be it factories, be it medical, and so on, power utility. There was a need to get electronics into other places. And one of the key benefits that we have of our technology is that ability to live in other places. And we can talk more about that in a moment. But at the edge, you've moved out of your core data center and you've got a very distributed world all of a sudden. You're living out in fields and factories and offices, as I said. And I think what goes with that, therefore, is that the customer needs a solution level fix to the problem. You can't just turn up with a whole set of components and say, there you go, sir. So what we were doing here is working with a deeply evolved ecosystem where people like Schneider could bring deep infrastructure benefit to us. So they have a significant supply chain and capability in racks and power and so on. So they bring that to the relationship. Lenovo are class leading in HPC. They're the most featured in the top 100 HPC sites. So working with them, and we've done our work with them in the past, made a lot of sense. And the SR670 server we worked with there and the next generations of it are, superb, highly performant technology. And they were excited about the opportunity for it to live in new places and to solve new problems. And then Avnet was about bringing together, again, a global class-leading solution provider who could take all those parts, who could take our IP, who could take components, servers, Schneider's materials, and build that together into a fully integrated, tested, supported, warranted solution that can be dropped to the customer's site, load your software, and run. So that what we've got there is global scale, global presence, full reassurance to the customer that every end of the supply chain and the solution is properly covered by people that they can, with necks they can choke, and that you can rely on to deliver a solution that works. So it was really that kind of productizing and maturation of liquid cooling into something that would be a highly valuable, highly dependable product at the edge, and left the customer really without any difficult choices to make. It doesn't become a conversation about liquid cooling. It's just, here is a thing that works. We can drop it here and you can start computing. Would you like one, sir? And I think that's the real change, is it's a full solution, fully delivered anywhere in the world and backed up with amazing, amazing performance.
Okay, and in terms of the solution itself, can you, you've obviously referenced the people involved in some of the contributions they've made, but can you actually describe it to us? And obviously you've talked a lot about the edge, and I know definition of edge is a bit of a grey area. So what sort of, what sort of size, I guess, of edge applications you're looking at, if that makes sense?
So the solution is geared towards a micro data center format, both in half rack and full rack, and delivering, anywhere between kind of 24 and 42 or so kilowatts of compute in that format, and delivering Lenovo servers today, but it's a form factor that can take other servers and other GPU types. So it's a completely agnostic solution, but we've partnered with Lenovo at this stage to do this early form factor. And at the simplest level, every server in the world today was designed to be cooled in air. They have fans, they have features, etc., that are there. So how do you mitigate and minimize the pain for the customer in getting them to where they need to be? And how do you remove the amount of hassle that they have in getting it there, and without trying to deploy all manner of difficult and unusual infrastructure? So we came up with a solution which effectively encapsulates the whole existing server in a chassis. So it fits into a standard rack, and it brings with it the capability to be popped open, to be serviceable, but to leave the thing as unchanged as possible inside. So we've got these GPU-rich servers, which are just operating at the best of their capacity, but in a chassis which is sealed and silent, so it can be deployed pretty much anywhere without you needing any kind of noise protection. And it's completely impervious to heat, dust, and humidity. So we think the solution is not just cooling, but protection. It allows us to live in places that IT hasn't lived before. And because of that, it becomes hugely enabling. To give an example, we have a customer that's deploying very soon 16 of these servers in a single rack. And they're a major engineering company that have a super confidential project. And what they're doing is delivering enough compute that would normally sit in about 6 or 7 racks, and we'd need a huge amount of cooling, into a single rack that's actually going to live in the room with the engineers in a hyper secure environment. So the silence, the ability to take up as little space as possible and to give them peak compute performance is the use case. So they're going to be able to do stuff that takes 3 days and do it in 2 hours. They're going to be able to do it with their engineers sitting, having something that looks like the stationary cupboard sitting beside them. It's just a black rack full of IT, but incredibly serviceable and safe, secure solution for them. So it was a way of removing fans, infrastructure, cost, and difficulty in environments that aren't suited to it. And that's really what we were doing. So the solution consists of effectively a tin box without holes. If you think of the chassis of a computer, it's a tin box full of holes. Well, we have a tin box without holes. We replace air with liquid, or most of the air. We actually don't use that much liquid. That's part of our IP. And then we replace fans with pumps. And what you have is a computer that's operating at peak capacity. It's perfectly well cooled. It's perfectly protected, and it's able to live in that whole new location, and to do so without needing to build, rooms and put chilling and all sorts of stuff into the loop. So it's incredibly flexible, and it could do that in the wild. You could have it underneath lampposts and overhead gantries, rooftops, brownfield, etc. So it's really delivering on the platform for the edge, allowing it to happen. And those components are what does that.
Okay, and in terms of the sort of wider cooling picture, I mean, I know liquid cooling is making significant inroads for many of the reasons you've outlined there.
Yeah.
But the air cooling folks would have it that they've still got a role to play. I mean, hybrid is, I mean, is used in almost every aspect of, I suppose, IT and stuff. Is that a reasonable assessment of the sort of cooling market going forwards, that liquid cooling has some sweet spots, but it may not just be used in what you'd call like general purpose data centers? Or do you think it will increasingly encroach on what's been, the air cooling market?
Yes, absolutely. It will absolutely continue to encroach on the air cooling marketplace. Certainly for the time being, it's going to be a very hybrid world. But if you look at the transition that we went through with processors through the 70s to the 80s to the 90s, you moved from bipolar processors to CMOS. We had major changes. Intel were able to start to move to multi-core processors that took power out and moved up and moved up. But we're starting to get now where we're really pushing the limits of what can be done in just re-engineering the technology, if you like, at the silicon level. So we are absolutely going to have hotter and more powerful componentry all the time. So inevitably, it's a bit like, I guess, motor racing. Formula One starts with features and benefits that are there, and they're kind of unusual, and then they hit high-end motor cars, and then 5 years or so later, they're in your mini metro and all of the other stuff that happens. So I just aged myself terribly by talking about 30 years old, I noticed there. So just now, because we design servers to be cooled in air, that's what we're going to do for a considerable time period yet. We'll retrofit and work with those servers, and liquid will become more popular. Increasingly, people will see the real benefits of liquid. We have to move past this idea that it's just about density and just about less electricity and so on. It's much more enabling than that. And I think as customers and users get much more comfortable with it and see that it fails less often, is a much better use of their built environment and space, reduces service, reduces all manner of downtime and difficulty, and allows them to get peak performance and allows them to do it where they want to do it. You'll see an acceleration in design towards it. Now, will that be 3 years, 5 years, whatever, I don't know, but it will begin to become dominant, and increasingly people will start to ship liquid cooled servers themselves. And particularly, our approach to chassis level liquid cooling facilitates that. It facilitates being able to bring all of that infrastructure into the chassis and to be able to ship it simply to the user, and it's plug and play from there on in. So it will become more dominant. The time scale around that will be a function of economy and how the market shifts. But inevitably, my own view is that the demand for data and the demand for speed is only going to increase. And that will drive a step change at a point. There will be a tipping point on this where you'll start to see more and more, and ultimately most servers being liquid cooled. But it will take time.
And one of the other areas that people talk about liquid cooling is the ability to harness the waste heat, to reuse that. I mean, is that a compelling reason for it, or as you've outlined, it's just the fact that computers are getting faster, hotter, and that's the primary, and the waste heat reuse is a nice little add-on if you can find an application? Or do you think there are people actively looking for that sort of possibility when specifying liquid cooling?
Yeah, they are equally important. Sustainability and technical performance are equally important. The issue to some extent, though, becomes about the market's ability to act on them. And the technical solutions are easier for people to get their heads around, the cheaper electricity, less water, etc., with a sustainability understanding to them. But things like heat recovery are incredibly important. The ability to use clean, sustainable energy to generate the electricity that you use in your data center, to use then less of it, to use fractions of the water that we use today, and then to be able to take the output from that and do useful things with it becomes the incredibly positive cycle. So, but it's quite a big ticket thing to deliver. You know, the people who run buildings and cities and planning and all sorts of stuff need to actually get their heads together and work on that stuff, which is why a lot of the smart city kind of stuff that we're seeing that's been successful so far is in much more kind of command-driven economies. So again, this is something people will become much more aware of the reality of it, and solutions will offer up really clear methods that people can deploy easily and simply, and then you'll start to see much greater uptake. So it's incredibly important, but it needs, frankly, a bit more vision and leadership from, you know, government advisors, consultants, and others, because most businesses don't know the impact that they have. They do not know the carbon footprint of their data. They do not know that they could have a much, much more effective offering. And you need to get out of pure technical, we could just blow fans harder type conversations and get into that much deeper conversation about what's our strategy, what's our sustainability, what do we want to be perceived by our customers. And I think a rising generation will demand that when they buy from people who have clear ethical standards, clear climate policies. So it won't be good enough to just tick a box and say, we're green, we promise. You will have to demonstrate that you're that as people consume it. So again, it's a trend and it's a point of movement, but heat reuse and heat recapture are absolutely vital. We have to join the dots better, and the industry has to create better leadership on new solutions that people can adopt. But definitely they are really, really important parts of the whole message.
And in terms of that sort of environmental awareness, I mean, clearly the industry as a whole is, you know, not unaware of these issues and has worked around them for quite a long time. Do you see, I mean, this year we've got, I mean, obviously the new American president sort of recommitted them to the Paris Agreement. We've got the UN climate conference, I think, coming up in the autumn. I think even the last month there was I can't remember, is it the carbon neutral, a European sort of, I think, associated creating a carbon neutral pact, data center pact, I think. Do you think do you get the vibes we're at a significant sort of tipping point, or are you a bit more cynical that it will take a little while longer before this sort of, you know, real drive, if you like, the next wave? I mean, you know, I'm rambling a bit, but, you know, renewables and the basics, everyone's done that, and that's the easy stuff. The difficult stuff, as you're alluding to, people understanding their impact and acting on it. Where do you think we are?
Yeah, it's a bit like quoting Churchill. You know, it's the end of the beginning kind of phase is where we're at just now. Most people, most users of data have no idea what the impact they have as they click on something on their phone or their laptop has, and the scale of it. I think as people become more aware, and they will become more aware of it, there will be a customer and a consumer-led demand for cleaner technology anyway. So there's something going to be pressing there to drive that change. And to some extent, the industry is a prisoner of its own success. As we've moved out of quite inefficient enterprise data centers into, you know, hyperscale cloud and co-location facilities, one of the great things that has done is give us scale and put more and more opportunity to really capture that stuff and to do it in ever more efficient ways. So everything we've done to date is a net and positive good. By having the very large scale data centers we've got, it's really allowed us to focus in and enhance efficiency and effectivity of those solutions. So, you know, huge credit to the industry that it's done that thus far. The other side of that, of course, is it's now become a much bigger target. Everybody can see these things and understand how large they are, and it's much more easy to say, gosh, we're using as much electricity as aviation and animal agriculture, or our impact, if you like, in carbon terms is there. And we're using, you know, obscene amounts of water. So, you know, these things are going to become ever more prevalent. So I applaud the industry for all it's done. There's a balance on economy and ecology. So people like us and innovators like us, we're bringing through solutions which are both CapEx and OpEx beneficial today. So we're giving people more economic reasons to act. And then I think the political environment, as you rightly allude to, will demand more innovation around this. You will see municipalities which will not allow people to consume the water that they do, that will demand carbon zero and even carbon negative for any new data centers. So technologies like ours aren't just ones to deal with a problem. We help you to solve those problems, but by allowing you to be building new data centers with smaller footprint in more places, we're actually a really enabling solution for a much brighter, bigger future, where you can take that technology and take all that learning from those core big data centers, deploy to the edge, deploy to where you want to. So definitely it's going to become a bigger issue. More and more customers will demand real evidence of good net zero type planning and technology there and present. And that constant cycle, I think, will be to our absolute benefit.
Okay, and maybe just as we finish off, in terms of Iceotope yourselves, I mean, it might be a bit premature to ask you about what the future holds when you've just launched this solution recently, but what can we expect from you over the next couple of years? I guess more of the same, or have you got some exciting? Clearly, I don't want you to give away any trade secrets, but some sort of hint as to where you might be headed would be good.
So we are an insanely ambitious company. And we've thought very, very hard about what we do. And we know that we're unique in being able to offer the breadth, the depth, capacity, and capability of our technology and offerings. We're absolutely, convinced that we can really make huge changes and impact in the industry. The work we're doing just now, and you're right, we have a lot of confidentiality around it. The first thing I would say is that the response to Cool 2, as we call it, actually, our edge data center here, has been stellar. We will be well into 7 figures of orders within a few weeks. And we have pipelines which are growing at a pace where we can see very, very, very significant volumes of business and more tier 1 players coming to town with us. So watch this space on announcements there. And in terms of some of our broader technologies, where we're working at the very, very leading edge, not just in servers and GPUs, but in spinning disks, hyper hot switches, you name it. We're working with some of the biggest names on the planet just now, building hundreds of kilowatts at this point in time of amazing test beds of solutions. And we're really excited about that. We have the capacity to really deliver a lot of exciting solutions there for people. So we anticipate very, very strong growth. We anticipate being definitely at least one of the darlings of the industry. We'd prefer to be the darling, but we believe we'll certainly be at the very epicenter of a lot of the change, because we've really worked hard to get that, and the traction that we have is in itself an evidence of very significant momentum towards that.
Okay, I mean, I've loved chatting to you today, David. So thanks very much for your time.
Thank you, Phil. It's been an absolute pleasure, and look forward to talking again.
Thank you.